Hey everybody, welcome to 5 Minutes With. I'm Ben Munson, editor at Medical Design and Development, and I'm talking today with Davy Orye, head of Additive Minds EMEA at EOS. Davy, thanks for joining us.
Thank you. Thanks for having me here.
Before we get started, would you quickly kind of explain what Additive Minds actually means?
Of course. So Additive Minds, in essence, is there to help our customers at EOS to be successful with our technology. How do we do this? Is by basically like three buckets of activities. On the one hand, we have with trainings, whether it's like basic trainings or very advanced trainings around like how the process works and so on. So that's like the first bucket. Second bucket is basically all around the application development. So starting from like creating a business case all the way to developing and implementing that application on our technology at a customer. And then thirdly is all around like implementation projects. So if a customer wants to go into serial manufacturing, they will need some consulting services around like the qualification aspect, for example, the factory layout and factory setup and so on. And so Additive Minds helps basically with this implementation project.
Okay, great. Thank you for that. I was wondering if you could provide like a quick 30-second overview of EOS's work in additive manufacturing in the medical space.
I'll do my best to do it in 30 seconds. So basically, EOS, we develop like metal and polymer laser powder bed fusion. And so the machines around it, and as I mentioned, we help them implement the technology with our customers, and of course also specifically in the medical industry. If you look on the polymer side with our SLS technology, we see the best applications around like surgical cutting guides and drilling guides, basically. We also see quite a bit of like dental and mouth applications like ramping up, whether it's like palatal expanders, anti-snoring, apnea devices, and so on. So anything where you need a combination of like patient-specific implants, right? And really good mechanical properties. This is the perfect fit for polymer technology. When we go over to metal, we see a lot of business on orthopedic implants, spinal cages, a lot of historically also dental. So there we see not only patient-specific, but also like large serial manufacturing. And we also see some smaller series and a lot of prototyping on the instrument side.
Great. Thanks for that. I wanted to talk a little bit more about your recent announcement with Tecomet and how the work with that company is kind of designed to help medical device manufacturers.
Yeah. So let's say additive manufacturing is already like quite established in the medical market. So a lot of the applications I mentioned before are already running in serial manufacturing. So we have basically gone through like that first phase of like early adopters who wanted to insource the technology, wanted to understand everything inside out, and then kind of create their competitive edge. Now we're at the second phase in this market where basically, companies are trying to catch up. So they see their competitors are doing really well with additive and they're trying to catch up, and they basically don't want to catch up through figuring it out all themselves, but they rather go for like more a buy strategy. So in other words, buying the parts of like expert users like Tecomet or other contract manufacturers. And so therefore we need, as EOS, if we want to approach those customers, we need a buy solution. Since we don't want to compete with our own customers. So in other words, we don't want to create like our own service provider network as EOS. We need partners like Tecomet, but also others in order to offer like the buy solution to our customers. For Tecomet, and the advantage, of course, is that by going together with us, they have access to the latest technology, the latest and greatest knowledge of the Additive Minds team in order to create a competitive edge compared to, service providers who basically go out on their own. And so we're leveraging, let's say, also their network and their expertise and the fact that they can implement the solutions which we offer to the OEMs.
That's great. What has the feedback been like so far from customers that are, like on the buy side, trying to catch up? Has this partnership been beneficial to them so far?
Yeah, absolutely. Let's say it also originated from like a demand. So it was not like Tecomet and us coming together and say like, hey, we should do something, but it was more like we had like more and more of these customers who were pursuing this buy strategy and asking like, what are your partners? And that's kind of like how it originated as well. It's like there was a demand, so therefore, yes, it has resulted also in business. So yeah.
Yeah, that's interesting. The way you describe it as this is a way that you can help these other customers while not competing with the early adopters. Was that like kind of a really key priority when entering this partnership?
Well, so let's say what was fundamental, or what is fundamental across all industries for us is that we don't want to build parts for our customers. We only want to sell them machines. So that and that's because we don't want to compete on the service provider contract manufacturing side of things, right? So that's where it comes. Whether it's now the early adopters who are using the buy strategy or the late followers, that's actually like has proven to be 50-50. So even the early adopters for, let's say, less strategic implants, or in general, less strategic projects, they also go to an outsourcing strategy because they can only do a handful of projects and but they still want to have like an impact with additive. So we actually see across the board, so both in new customers, let's say, as well as like in some of our old or first early adopters, we see that they do a combination of this make strategy, buying systems of EOS and developing it potentially together with EOS, the application, as well the buy strategy, where EOS is basically helping in the background companies like Tecomet, but also others like Linkotech, for example. We also do this often, helping them out in order to create the best solutions for these customers.
Okay. Yeah, that makes sense. Um, you know, EOS medical applications, they already include like implants, surgical instruments, and prosthetics. I was wondering if you could maybe talk a little bit more about how you see those applications expanding, either within where they're currently at, or even like expanding out into new applications for the technology.
Yeah. So if you start with like the implants, we see that's of course like a really broad group of applications. So where it started with like the spinal implants, like very small, highly complex parts. So business case is very easy. Similar for like the hip cups. And for the dental applications, we see also larger implants and less complex implants starting to be additively manufactured. So an example, for example, are femoral knees, where in the past it's a casted part, and the costs difference between casting and additive was so big. But now through multi-laser systems, through reductions on the cost on the powder side, reduction in the cost of making the machines, and obviously faster and better processes, we're able also to tap into markets in the implant side, which were before deemed, impossible from a costing point of view. So additive on the femoral knee specifically, for example, we have much more flexibility on the manufacturing side. So lead times of castings are through the roof. So we, as with additive, of course, can have much shorter lead times, much more production flexibility. We can obviously also add a ladder structure really easy. So we're tapping into like new implants, and basically not a single implant, which is like casted or forged or something. We are not competitive anymore in terms of price. So also, for example, hip stems. We're starting to see some traction because we're meeting even forged mechanical properties and fatigue, and we offer them all the added value of additive. So, first statement is like we see just more implants being cost effective to print. But then we see also like new applications outside of implants. Let's say I already talked about the dental in-mouth on the polymer side, and the apnea devices, and anti-snoring devices and so on. So there's like quite a bit of like traction on SLS. What we also see, for example, is a trend in orthopedics, or in general in surgery, is more and more robotic arms in the surgery rooms. Also there is quite a bit of, let's say, additive parts, whether it's metal or polymer for brackets, lightweighting, like all these typical advantages of AM come into play also like in this machinery. And then also in the production in themselves, so like jigs and fixtures for whatever reasons, so like if you've ever been to a medical production facility, there's so much, production, jigs and fixtures, setups, and so on, where additive can also like play a role, and where some people in the industry even claim that the potential on polymer side is even bigger than, for example, on cutting guides and so on. So yeah, we see more and more application across the board. But that being said, the focus of 3D printing is still around the implants, is still around the patient-specific implants, but also like the big serial volumes, since we are so much better in cost per part than 5 years ago.